Hello, I'm Jerry Winslet, along with Kenneth Ezell, and we'd like to welcome you to the digital classroom brought to you by HD Supply. Before we begin, I want to tell you that if you have questions about anything we're going to be covering here today, you can ask those questions using the chat feature, which is on the right-hand side of your screen. Just type that chat in, and we'll get to those questions after the show today, after we're done with this section. Anytime during this class, you can type in those questions. You don't have to wait till the end of the show. You can do that anytime, and we'll get to as many as we can. But how are you doing today?
I'm doing well. How are you?
I'm doing great. Today we're going to be talking about electric water heaters. We're going to be talking about troubleshooting. We're also going to be talking about some tips that is going to make your job a little bit easier, some time-saving tips. I know your time is very important doing the kind of work that you do. You've got a lot of things that on your plate during a day, and getting to, if you're like working in the apartment industry where you have a lot of different apartments that you're responsible for, water heaters is just one thing of a lot of different issues that you might run across. So what we're going to do today is we're going to try to give you some tips that's going to make that a little bit easier for you for your day, and give you some ideas that'll help that water heater maybe last a little bit longer, and that will help that water heater for future use. So let's go ahead and get busy. The first thing I want to talk about, since we are talking about electric water heaters, and some of you deal with a lot more than just that, having the right tools for the job is a very big time saver. So one of the things we want to talk about is the right tools, and this is an example of something that might be useful in the future. This is a toolkit provided to us by HD Supply, but it comes with a lot of different things that's going to be very handy, not only for water heaters, but for any other issue that you might run into during the day, because you're going to be dealing with a lot of stuff, from light bulbs to,
weather stripping.
Yeah.
In apartment maintenance, you run into a lot of different issues. You'll get calls to go take care of several things: dripping faucets, the weather stripping's leaking around a door, or my water heater's not working. So this has several different hand tools that are great for all these types of instances.
Yeah, and this all comes together as one piece. All the tools came with it. Plus, if you're doing water heater work, especially like gas, I would probably add some open-end wrenches to go along with this, and maybe some pipe wrenches would be great. As an added feature with this would help out a lot, and it's a big time saver, and we're gonna use some of it in a moment. Now, dealing with just the water heater, now this is an electric water heater, so we deal with electricity. We have to have the right meters to diagnose that. So here's a couple of different things also. This is an electrical test kit that comes with an electric amp meter, a voltage meter, and it also comes with a non-contact voltage tester to see if you have power or not, and then a plug tester to see if the plug is working properly.
Correct. So this is a whole kit that's involved, or that comes together, but you do have the multimeter. This is just a typical multimeter like you'd see every day. A couple things about this meter: it does have a digital display. It does have a pretty wide range, so we can check a wide range of appliances and different things. This one is you have to manually set the scale or manually set the range, which means you have to be pretty familiar with what you're looking for, because you always have to set it a little bit above the expected reading. So you have to move it around. You have to be kind of on top of your game to remember.
Yeah, so you have to know
stuff.
what you're doing when you're dealing with that.
Yeah, and it's
what
hard,
the range is.
And it's hard to remember numbers, so I'm usually not into that. It's hard enough to remember what something should read, but then I have to remember what scale to set it on.
Exactly.
So that can become kind of difficult. A more upscale option, or a little bit fancier option, is this digital meter that's auto ranging. Meaning that it'll automatically find the correct range. So I don't have to remember what range to set it on. I just set it to voltage, or I set it to resistance, continuity, whatever. It'll automatically go to the correct range.
Okay.
It also has a clamp-on amp meter, which makes it speedy if you want to check to see if the water heater's working.
Yeah, that's a time saver right there, especially if you got a lot of different water heaters in one location that you have to check. You can just walk around and just check those wires going to that element, and if it's given amps, the correct amount of amps, it's working.
Correct, and one of my other favorite features using this meter is that it's backlit, because a lot of these water heaters are in dark closets or different things like that, and so when it's backlit, it's easy to see. It actually has a little flashlight on the top. Here you can kind of see it shine on my finger. So it kind of lights up whatever you're checking above it, or if you need to look at something, it's all right there in the palm of your hand.
And these are also available at HD Supply. Just get with your local sales rep. I think we put some part numbers up there for you if you're interested in something like this. This is what we recommend to work on these water heaters. Just go ahead and contact your sales rep, and they can get that for you. So, okay, so what we're going to do now is we have the right tools. Now we need to go talk about the water heater. Now, the water heater that we're going to be discussing is a 40-gallon lowboy. It's a short water heater, and it's a typical water heater that you might put in apartment complexes underneath like an air handler or up on a shelf. It's a water heater that you see a lot. Some of you see a lot. And it can be difficult because of the space around that water heater. You may not have enough of it. So, we're going to go over there, talk about that water heater, talk about space, and talk a little bit about replacing an old water heater and putting in a new one. So let's go over there. Got it? All right, we put it on a stand because that way we can talk to you. It's a little easier for us. It's not hooked up.
Our backs aren't as good as they used to be.
My knees are bad. You know how it is. But like I said, this is a lowboy. This is a short water heater. They put these water heaters in underneath, in tight spaces, underneath air handlers. So it's difficult sometimes when you're putting these water heaters in. Installation becomes an issue. And now this is a new NECA 3 water heater, which is a little bit larger and a little bit taller, and so space becomes even more of an issue. And one of the things, we're going to do this in the future, but we're going to, maybe next month we could do or in the future we could do a show on installing an electric water heater in a tight area. That'd be good for us. But right now we'll talk a little bit about it. And like I said, we can do more in the future. Just let us know and we can do that. But this is side connect, so this is a little bit easier than, say, our standard or some of the top connects. We offer top connects and side connects.
Yes, if this is in a closet to where it's going to be under an air handler, or even if it's in a crawl space below a house,
right,
wherever it is. But say in this case it's going to be into an apartment, and so it's going to be in a small closet. Side connects are a lot easier to get in and out because you do not have a lot of overhead room.
Right.
And so that's why you're using a lowboy typically in the first place. So that's what we call this, as a lowboy water heater. So you have your side connects, your hot connection. The hot water comes out at the top on the side. The cold water goes into the bottom. And it just gives you a lot of overhead clearance. So you have plenty of room typically to go above.
Yeah, and a tip would be, if you're pulling one out and putting in a new one, I mean, look at getting some push-on connection like Shark Bite or something like that, that makes the connections a lot easier, the plumbing connections a lot easier.
Yeah, this is going to be in a tight space like a closet. So usually soldering something, you might burn the wall, or it's going to be in a real tight spot, hard to get to.
Yeah, and you don't want to do that around these connections either. We got plastic in some of these, and we couldn't melt that dip tube.
Correct. So, and it's quick and easy. I don't have to carry around a torch. My torch doesn't run out of gas. If I use Shark Bite fittings or the push fittings, screw it to the water heater, push it into the pipe, and I'm done. I mean, it's quick and easy.
And some of those fittings are actually flexible too, so if we need to bend it in a certain way, you're not going to cut that water off.
Yeah, a lot of them are like stainless steel braided flex hoses, so they're real strong and very durable.
So that's something too that is available at HD Supply. Talk to your local sales rep; they can do that. But that's a little bit about the install that would make it a little bit easier, quicker. But because time is very important when it comes to working on these water heaters. So anything that we can do to kind of help you out, we're going to do that for you and give you some tips about that. Now, on this NECA 3 water heater, some things did change. Not only did it get bigger and wider, or wider and a little bit taller, some of the features on it, we kind of went across the board and did some changing. We went with the full port drain valve. Let's talk about that.
Yeah, we went with the full port drain valve instead of the old type that we used to use. And there's several benefits or features and benefits that are better. One, it comes out straight.
Yes.
So it's a lot easier to hook a garden hose onto it to flush the water heater, or when it comes time to drain the water heater. It is a full port valve, and so it has a lot larger opening. So if you're draining the heater or flushing the heater, Sediment's going to come out a lot easier if you're flushing it, and when you drain it, it's actually going to drain a lot faster.
That's it. It's going to be faster. It will be a little quicker. And if you do have to do some type of flushing, maybe a maintenance checkup on it, you're able to do that a lot quicker as well. All right, so another thing that we did on these water heaters is on the lower element, we went with a low watt density alloy element. They last longer, correct?
Yeah, they last longer, and I have two examples I can show you. In my left hand, I have a high watt density element, and if we can get kind of a close-up of that, you'll be able to see it. But a high watt density element, if you look at it, it just loops over one time. And then in my right hand, I have a low watt density element that's made from alloy. Now the difference between these elements would be it's the amount of surface area. I'm spreading the same amount of power or same amount of wattage over different surface areas. Right. So when I spread 4,500 watts over this one, the high watt density, and 4,500 watts over the low watt density spreads the heat out more. It's less stress on the sheath of the element or the surface of the element, which typically is going to make it last longer. Another good thing about it's alloy, meaning that the material, it's a type of stainless steel that the element's made from, it doesn't build up sediment on it near as much.
Right.
Or as bad, and so it keeps the element clean, it keeps the element efficient a lot more versus a zinc-plated copper element.
Yeah, so that's going to last longer.
Yeah, it's going to last longer, and so what we do, we put the alloy element in the lower part of the tank, because the lower part of the tank heats the most water, and we just put the high watt density in the upper part of the element, or the upper part of the water heater, because the upper element, if the heater's sized properly, is rarely going to kick on.
Right.
It will when the heater's brand new. But other than that, it's rarely going to kick on. So if we want to put the element that's going to last a lot longer in any part of the tank,
right,
we want to put it in the bottom because the bottom's the workhorse.
Okay, let's talk about the water heater now before we do anything else. Let's talk about how it works, because I want to talk some troubleshooting, and then we'll get into some maintenance in a moment. But you know, how does this electric water heater work? Now you're saying that the bottom works more, but explain that to me.
All right, well, first we'll follow power, like how it installs, all right? So the power wires from the home come in and connect to the junction box that's on the top.
Okay.
Usually it's connected with wire nuts, and it's something that we're all familiar with, and then we have a ground wire that attaches to the tank with the screw.
Okay.
All right, so power then goes to the top two screws of the upper thermostat, and if you want to remove that.
We'll go ahead and take this off here. So it comes in up here on the top thermostat.
Correct. So when you move this out of the way, you'll kind of see, and we can hold this up. Now I want to remove this thermostat protector that covers everything. So power comes in from the junction box on top. It goes down to the top two screws of the upper thermostat.
Okay.
It's usually a good place to check to see if the water heater has power if you're troubleshooting that way. But then power then goes to the bottom, past the red reset button, which is the ECO, and I'll explain that in a minute.
Okay.
Goes to the next screws. Power then goes to the upper element from the upper thermostat. That heats the upper part of the tank. And so the upper element, when the tank's completely cold, kicks on, heats the upper third of the tank.
Okay.
Then when the upper third of the tank is satisfied for temperature, power then goes to the bottom part of the tank.
Let me go ahead and take that off as well. So. Okay, so what you're saying is power comes in at the top here, goes through that red reset button, that ECO, and we're going to talk about that in a moment.
Yes.
Goes through the ECO, and then we power the upper part of the tank. This element gets its power, and it's going to run until the upper part of the tank is satisfied. This thermostat has to be satisfied. It comes up to temperature. Then we transfer power down to the lower part of the tank, and I'll go ahead and take this cover off as well.
Yeah, a lot of people think because a water heater has two elements, both of them work at the same time, and that's not how they work. When the tank's cold, the upper thermostat and the upper element come on first.
Okay.
And then once it satisfies the upper third of the tank, the transfers to the bottom, which heats the lower 2/3. Now, when the tank heats up and it's satisfied for temperature, if we used to draw hot water, like say we're going to take a shower or wash our hands or something, cold water enters through the bottom of the tank. If it's top connect, it comes in through and goes down through the dip tube.
Okay.
On this heater, it's side connect, so it come into the bottom inlet down here, which is going to cool the bottom part of the tank, which is going to cause the lower element, the lower thermostat, to come on when it calls for heat.
And that's where we were talking about the lower part does most of the work, and that's why we put that alloy element in there, so it's going to do most of the work.
Correct.
If it's sized properly, like Kenny said, it's the top part rarely ever comes on. Now, I mean, you know, in some situations, and this is out of our control, if you get somebody like an apartment, if somebody moves in and they bring in more people than what they said, and you got a lot of people there, or it's over the holidays or something like that, you could be using more hot water, and that's whenever you get those calls saying, I don't have enough hot water and things like that, because it's undersized. It's not being able to keep up with the demand.
Correct.
A normally correctly incised water heater will be run from the bottom element running all the time, really. I mean, that's what's doing all your heating, is the lower heating element.
Yeah, like I said earlier, it's the workhorse, so it's the one that works the most. And so typically if a part's going to fail, it's going to be the parts that work the most. And so, you know, eventually that's why we're, like you said, we're going to put the strongest element in there, the best lasting element in the bottom, because we know on a correct installation, it's going to come on and off the most and do most of the work.
Again, if you have questions about anything we're covering here today, go ahead and put that in the chat feature, which is on the right-hand side of your screen. Just go ahead and type that in, and after we get done, we'll go ahead and answer as many as we can. So, all right, so that's how this works. Every time we draw in hot water, draw hot water out of the tap, we're putting cold water into the bottom of the tank.
Correct.
And the lower heating element and thermostat heating element is energized first. Heats up the lower part of the tank, 2/3 of the tank, and then until it's satisfied. And if it's totally cold, then our upper heating element's going to kick on first.
Yeah, say on a new installation or when the tank's completely cold, the upper element and the upper thermostat are going to kick on first. That's why on a new installation, say you just performed a changed out and changed the water heater, it's important to get all the air out of the tank before you ever turn on power. It has to be completely full of water before you turn on power.
Exactly, and that's one of the things. You don't want to dry fire that upper heating element. So, you know, a good tip is to go ahead, don't even connect your power. Connect all your water lines. You know, once you've got it all installed, before you connect power, go ahead and run all the hot water faucets and make sure that they're running free, no spitting and sputtering for at least 3 minutes. So we get all the air out of the tank, then apply power, and then turn on the water heater. So that's the easiest way to do that, so you don't dry fire an upper heating element. Okay, so that's how the water heater works. Now let's talk about troubleshooting, because most of the time the calls that they get is usually no hot water at all. You know, they don't have any hot water. And, you know, because nobody calls and says my water heater's working perfectly, everything's great. Yeah. They always call saying, I'm cold and it's not working.
Yeah, they only call when there's a problem. They never call and tell you how great something's working.
No.
All right, so no hot water. It could be a couple of different things. First thing I always usually check is to make sure that the tank is cold.
Right.
Easiest way to do that, I have this nice brass relief valve. Usually it could be on the top or it could be on the side, but you're always going to have a relief valve. I just simply touch it.
Okay.
If the relief valve's hot, but the complaint is no hot water, then you have another issue. That doesn't involve the water heater. It's usually going to be something in the plumbing or something going on like that.
So we know the water heater's working if that's hot.
Yeah, we know the tank is full of hot water and something else is causing nothing but cold water to come out of that
so you're going to want to have to check a lot of other things. I mean, but you'll know that the water heater's working properly.
Correct.
Okay, let's say that we walk up to it and it's cold. What are my steps?
All right, if I come up to the water heater and this is cold, the first thing I'm going to do is go to the breaker and turn the breaker off.
Okay.
Right, and once the breaker's off, I'm going to come to the water heater, remove this upper access panel.
Okay.
Now, when you remove it, it's going to have the thermostat protector that you saw, but you'll see that red button or ECO. That's the first thing I'm going to check. This red button, like I said, is an energy cutoff or ECO. It's a safety device that cuts power to the elements if the water becomes too hot.
Okay.
And if that ever happens, you'll still have power to the heater, but power won't reach the elements.
Okay, so I'll have power to the heater, but it will not be going past this ECO.
Yeah, it will not go past the ECO, yes. But that means the water become too hot, usually more than 170 degrees. And so what we're going to do is press the button. If you press the button and it clicks, that means the water got too hot. And it's caused by one of two things. First thing would be either a grounded or shorted element. The second thing would be a stuck thermostat. So I'm going to have to do a little bit of checking to see what the problem is.
Okay, so if you have to press the reset button and it does click, that's not the time just to go ahead and button everything back up and move on.
Correct.
You do have a problem if you have to press that reset button. And let's talk about that. What's the most common issue whenever it does click?
The most common issue if the reset button is tripped is usually going to be a grounded or shorted element.
Okay.
Now, that's something you are going to require a multimeter to check for.
Okay.
And I can kind of give you an example of how to do this. Let's see. I need a Phillips screwdriver, Jerry. You see a Phillips screwdriver?
Yes, I do, right here.
All right here. All right, so using my multimeter, I'm going to turn this to the ohm setting, which is, or continuity setting, which is usually shown by kind of like a Wi-Fi symbol or an upside down horseshoe. And then let me click this around this wire just to hold it for me. Can you hold that up?
Yep.
All right, so to check for a grounded or shorted element, power's off. I remove the two wires going to the element.
Let me do that.
Just bend them out of the way. And you can hold that meter for me, Jerry, once I remove this wire.
There you go.
So I move the wires out of the way. My meter is set to continuity, meaning I'm going to have usually an audible beep whenever I touch the leads together. And so what I'm going to do is touch each screw on the element to a ground. Now the tank is an excellent ground because it is grounded, or you can use the thermostat bracket, which is kind of easy to see.
Okay.
So I literally just go from each screw to the ground. And my meter should not change and my meter should not beep. And you can see on this one, it's not changing, it's not beeping. Now, if it was to beep or the meter was to change, that would mean that the element is grounded and needs to be replaced.
Okay.
Now, you want to check both elements when you do this. I just did it to the upper one, but you get the idea. It's the same thing. Remove the two wires from the element, each screw to the inner tank, which is ground. And if it beeps or the meter changes, that element's grounded. That's why it's overheating, and you would need to replace that element.
And if you're going to replace the element, if you come to that situation where you're replacing the element, another thing that's very handy to have is the right type of a tool for that. We do recommend an element socket. An element socket is very important to have this because it's going to be a time saver and it's a lot easier to use. You can also use the breaker bar, which it's a flexible breaker bar that I don't have one with me, but we offer that as well. But you can use that. It fits right on the element and you can get it out very quickly and easily. But that's a big time saver.
All right, and so if you check the elements and the elements are good, meaning they're not grounded, then the next step, the only other remaining possibility is a stuck thermostat.
Okay.
And so if I check and I have a stuck, if the elements check good, my thermostat must be stuck.
Yeah.
So I just replace the thermostat.
Okay. All right. So that's if our ECO is tripped,
Yeah,
right?
if the reset button is tripped.
Okay. Let's talk about what if it hasn't tripped.
All right. So once we check it and the reset button hasn't tripped, then what we're going to do is we're going to go ahead and remove our thermostat protector. Then we're going to go back to the breaker box and turn back on power.
Okay.
And so you're going to want to be careful because you are working with live voltage from this point on.
Right.
But simply what we're going to do, the customer has no hot water. We know the upper element kicks on first in a tank with no hot water. The reset wasn't tripped. I'm going to check for power at my upper element.
Right.
If I have power but no hot water, the upper element's bad.
Okay.
Typically. Now, it's one or two things. It could either be the upper element's bad if I have power but no hot water. The only other remaining possibility is a plumbing issue.
Right.
And so it's either going to be a leak on the hot water side of the plumbing or the upper element's bad.
So the quickest way for me to do that is just to turn power back on, and I'm going to check here at the two screws.
Yeah, check between the two screws of the upper element. If you have power, no hot water, change the upper element.
All right, so that's a little bit of tips on troubleshooting, you know, a no hot water call, because really, I mean, that's really what you're going to get calls on.
Correct.
So the easiest way to do that is, you know, you're going to come to the water heater and verify that it is no hot water. That's really what you want to do. So you can. A quick tip on doing that is to go ahead and check that relief valve to make sure it's hot. You know, some other things I want to talk about too before we move on is, you know, some routine maintenance that may help this water heater last a little bit longer when we have these installed. We're installing these in some of these apartments and things like that. So, you know, some of the life expectancy of these water heaters may change from time to time depending on the environment it's in, and, you know, the kind of maintenance. And I know we don't have a lot of time to do a lot of the maintenance on these water heaters that you probably should do because of the time you have with it. A lot of times, you know, you may be looking at this water heater twice a year whenever you're coming in there and inspecting the apartment. Or if, you know, you're doing a change out where somebody's moving in, you might go in there and look at it. But, you know, we're going to give you some ideas of something to do real quick just to visually check the water heater, and that might help the water heater last a little bit longer. One of the things that affects water heaters is water pressure. Water pressure is very important. If you have too high a water pressure, it adds stress to the water heater, and it's going to break down a little bit quicker than it could last. So, you know, having the right water pressure, we recommend 50 to 60 psi coming to this water heater. Make sure that it's you know, a steady pressure. And let's talk about that, because what does it do to the water heater?
Well, the thing is, I mean, water pressure is going to fluctuate unless you have a pressure reducing valve, but what it does is this. Pressure is typically going to be low during the times of day people are using a lot of water, usually typically in the mornings and then in the evenings. All right, then at nighttime when everyone's asleep, or during the daytime when a lot of people are at work, that pressure is going to creep up because the pumping stations from the water company are pumping all the time. And so just think about it. I mean, it's going to expand, because when you pressurize something, it's going to want to push that metal out. And then when you're using it, it's going to contract and going to want to push it in. It's just like if I was to get a piece of metal and bend it back and forth, it's eventually going to break.
All right.
You know, it's eventually going to crack. And fluctuating or high water pressure is going to do that. It's going to be a constant force on the heater and eventually cause it to break if the pressure's too high.
Yeah, and that's something, I just want to keep this in mind. You know, adding a pressure reducing valve may be something that you need to be looking into doing, especially if you've got high water pressure coming to the water heater. Another thing is, you know, and a pressure reducing valve looks similar to this. And I know space is an issue when it comes to these water heaters, but if you're replacing water heaters prematurely, look at that water pressure coming in, and if it is high, try to get that thing under control. That way the water heater will last longer, and it's going to help you in the long run, as opposed to just a quick fix and putting in another water heater. Now, another thing too, to go along with pressure, is thermal expansion. Thermal expansion tanks are a little bit different because, you know, this has got to go on the cold water line as well. The advantage to a thermal expansion tank, again, is it protects the tank.
It protects the tank, yeah. When water's heated, it expands. And a lot like water pressure fluctuating, when the water heater kicks on to start heating water, water's going to start expanding. That water needs somewhere to go. Right. And the expansion tank gives it somewhere to go. A properly sized expansion tank is going to absorb all that excess volume of water and stabilize the system, meaning that the tank itself, or the water heater, is not going to see wild fluctuations in pressure.
I don't know if you can get a shot of it over, Heather, over Kenny's shoulder right there is a thermal expansion tank that's installed on our wall here. I'll let her set that up for a second. But it really, you know, a properly sized thermal expansion tank is recommended on any application where you have a closed plumbing system. Yeah,
if you have a closed plumbing system, meaning the water system uses backflow preventers, we'd always recommend
There's one right there.
Have an expansion tank.
Yeah, and what that does, it holds that water until that temperature subsides, and it just, you know, puts it back in there. And the thing about a thermal expansion tank is pressurizing it before you install it. What you're going to do is you're going to pressurize that thermal expansion tank to whatever the incoming water pressure is. And you want to do that before you install it. A lot of times people buy thermal expansion tanks and they put them on, you know, they put them on, then they put the air in them, and what happens is they're not properly pressurized. So you do that before, and then you put it on and it'll work properly.
Yeah, not enough air in an expansion tank or too much air in an expansion tank all equal that you do not have an expansion tank because it's not going to work.
And again, with a thermal expansion tank, space. Where am I going to put this? I mean, we recommend on the cold water line. Now, it can be really anywhere if it has to be. I mean, if you don't have room, but it's going to last longer on that cold water side.
Yeah, it's going to last longer on the cold water side. You could put it anywhere. I'm always going to recommend on the cold water line between the water heater and any check valves or shut-off valves.
Yeah, so, you know, when you're looking at doing that, that's going to help add life to the water heater. Another thing, too, is flushing that water heater. And sometimes you can do this on a routine maintenance checkup. Come in there, and given our new full port drain valve, that's going to help as well because, you know, it's a lot easier than it used to be because those were turned down and it was hard to get the, maybe a little bit difficult to get the hose on there. But these are straight port and full port, and it's going to flow easier. Yeah,
with the old style drain valves, if you had chunks of limescale or sediment built up in the heater much larger than a grain of sand, it wouldn't come out because of how restrictive they were. But with the 4-port valve, I mean, it has a large opening in it. You can get some pretty large chunks through there. And so it makes it a lot easier flushing it. It doesn't take near as long to flush it. Just open it up, allow it to run until you don't get any chunks or material out anymore, and then you're done. It usually takes less than a minute.
Yes, and you can do other things while you're flushing it out. You can inspect the water heater. You know, you can turn power off to it, look at the, open up the panels, make sure it's not leaking, or inspect the wiring. Just things like that. Look around the water heater for any water, if it has been any water damage or anything like that. Just look at the water heater, and you can do that while you're flushing it. But, you know, because maintenance on an electric water heater is a little different than gas.
Yeah, there's not the same amount of maintenance on an electric water heater as you would on a gas heater. Gas heaters, you have to clean filters and check a lot of stuff. But the electric heater, just check it, make sure you don't see any water leaks, make sure none of the connections are leaking. You can even check it, as Jerry said, inspect wiring, make sure the elements aren't leaking to where they screw into the tank. Inspect the relief valve to make sure the relief valve has not been discharging.
Exactly, yeah.
Because if it is discharging, that shows you have high water pressure or thermal expansion.
Yeah, and we need to get those under control so the water heater will last longer. But right now what I'm going to do is turn it over to you. We're going to go back over to the desk and answer any questions that you might have. But let's go ahead and go on over there. All right. Before we get to questions, got one more thing I want to talk about, and that's insufficient hot water. I mean, we talked about no hot water, but there is also situations where you're running into insufficient hot water. The customer calls, says, I'm not getting enough hot water.
Yeah, typically if a customer is complaining that they're not getting enough hot water, if it's something that has changed, you know, they were getting enough hot water, but like the weather hasn't changed or the amount of people using it hasn't changed, it's just changed, that's typically the lower element has failed.
Okay.
It's actually something you're going to see a lot less on these newer units since we're using the Incaloy lower element, so we're using the best lower element you can pretty much use, so the element's going to last a lot longer. But typically, if it's not an expectation issue, it's typically going to be just a bad lower element.
Yeah, because the upper part of the tank is the only one doing the heating at that point.
Correct. And you can check the lower element. You can ohm it out to make sure it's good. It's kind of hard to remember those readings sometimes, like I was talking about earlier, what it's supposed to read. So typically what I recommend is getting a good element that you know is good because it's brand new that you might carry in your bag or in your truck or something. Test it. Then test the element in the heater. If the reading's about the same, then you know it's good. Or if the reading's very, very different, then you know the element in the water heater is bad and just to replace it.
All right, okay, so what we're going to do now is we're going to answer some of your questions. We have a couple of them here. Let me go through here. The first one is, are expansion tanks important, is what I've got the question.
Expansion tanks are very important. Anytime you're on pretty much any water system, but really a closed water system, you're going to put a lot of stress on that heater because water expands when heated.
Right.
So the tank's going to expand and contract. Like I was saying earlier, it's going to bend the metal. So it's very important when on a closed water system to use a properly sized, properly pre-charged expansion tank. And just as a reminder, to charge an expansion tank, you do it while it's not even hooked up. You check your water pressure over a 24-hour period. record your water pressure. That's how much air, whatever the water pressure number is how much air you want in that pump, that pressure tank, completely empty of water. Pre-charge it, install it on the cold water line, and you should be good to go.
Yeah, and not only does it protect the water heater, but it also protects other appliances in the house that use water, toilet valves, things like that.
Yes.
That's, expansion tank is very important. We highly recommend using expansion tanks.
If you hear your toilets running at night while you're sleeping and chatter sometimes when different appliances kick on and off, like your ice maker and washing machine solenoids, that's usually a sign you need an expansion tank if you go through a lot of toilet valves and things of that sort.
All right, I hope that answers your question. The next question is, my water heater makes a lot of noise, I think due to limestone buildup. How do I clean and flush when the hole isn't big enough? And I think they're talking about the drain valve. Well,
the thing is, on an electric water heater, you're going to get noise from limescale buildup when it forms on the element itself. Now, flushing and draining the heater, especially with this new heater, is a lot better because it does have a large hole in it. It's a full port valve.
Right.
I mean, I can almost stick my finger inside the valve. The hole's so big. And so it shouldn't really be a problem getting any sediment out there. But the thing is, and this is where electric differs from gas. On a gas heater, the sediment cooks to the tank. You have to use like a sediment dissolver.
Okay.
To get it
so
off
some
the
type
bottom
of
the tank.
lime away, or like something that's going to, not lime away, but something that's going to take that lime, de-lime the unit.
Yeah, you'd have to descale the unit, correct, or de-lime the unit. An electric water heater, if you're getting noisy operation, that's usually going to be because the lime scale's built up on the elements. It's typically best just to replace the elements. The elements aren't really an expensive item. They're typically pretty inexpensive. You wouldn't want to take them out. If you're going to take them out and descale them, you might as well just take them out and replace them.
Go ahead and replace them.
And so that's what I'd recommend.
All right, I've got another question here. It says, I understand that the A.O. Smith electric 50-gallon water heater can be replaced by the new, I guess the smaller size, the next size down, which would be the Model 40, to maintain the same dimensions. That's what they're saying. So they're saying that, I guess what we're getting into the NECA 3, if the larger 50-gallon tank is a little bit larger, because it's a little bit taller and a little bit wider, they can as an option, they can step down to a 40-gallon tank. How would we do that? Now, we would have to involve a mixing valve in that case.
Correct. If you don't have room, or if, depending on the 50-gallon heater, if it's a 50-gallon low boil, we no longer have that.
Right.
And so there may be situations to where the same size model will not fit anymore. You do have the option to go to the same gallon capacity model with the blanket that's a little bit bigger, but there may be situations where that won't fit. So you could go to the unit that's one size smaller and increase the temperature up to usually at 140 degrees. The important thing about that is anytime you increase the temperature of the water heater above 120 degrees, you increase the risk of scalding. So if you were going to do that, downsize to the next model, you can increase the temperature, install a mixing valve, and you'll get just about the same amount of water as you did from the big heater.
Yeah, because I mean, you would take your smaller water heater, turn it up to 140, install a mixing valve. And what you're going to be doing is using less hot water, because the water's hotter, you'll use less hot water and add more cold water.
And I'll say 9 times out of 10, most people won't even notice the difference.
All right. I hope that answers your questions. And we also we recommend not only a whole house mixing valve or the apartment mixing valve, it would be more point of use, at each point of use where you're drawing hot water.
Yeah, you could have a whole house mixing valve or a point of use mixing valve, but keep in mind that most shower controls today have built-in mixing valves. And so they may already have some, at least at the shower points, to where you're going to have maximum contact of your water and your skin. But typically you do want hotter water to go into a dishwasher or washing machine. But anytime the temperature is turned up above 120, you do want to install at least a mixing valve set to 120 to temper that water back down to a safe temperature.
All right. I think, let's see, we've got a couple more questions here. Let's see, is the only way to check heating elements is to disconnect the wires and ohm it out?
All right, so I mean, yeah, a heating element, the way to properly test it is to usually ohm it out. So to ohm it out, you want to break the circuit. And by breaking the circuit, I'm meaning you want to remove the wires from the heating element. So yes, you would want to turn off power and remove the wires from the heating element to ohm it out to check to see if the element's good. A typical heating element's going to ohm to around 13 ohms. And if you're testing for a grounded heating element, it's pretty much the same thing like we was discussing earlier. Turn off power, remove the wires, test each screw to ground or the thermostat bracket, which is a good place, and you shouldn't get a reading. But yes, you do have to remove the wires to ohm the element and to get an accurate reading.
Mm-hmm. All right, I think we have another question here. It says a circulation pump helps out a great deal to push hot water to where you need it. Now, let's talk about circulation pumps would be in a situation where we would need something like that with an electric water heater?
Usually you need a recirculating pump if you have a bathroom that's pretty far away from where the water heater is installed, because think about it. If the water heater's 35 feet away, you might have 35 or more feet of pipe between the water heater and the shower. And so before you start getting hot water from that shower head or from that faucet, you have to push 35 feet of water out of it. So in some cases, especially in larger ranch homes, you don't see this in apartments too much, but they may install a recirculating system that constantly circulates the water on the hot water side. That way hot water is instantly available whenever you turn it on. Now, using a circulating system can cause more wear and tear on some of the parts on the heater. Usually I'd recommend using a timer on one. That way when you don't need it, it's not running. Like while everyone's gone, you wouldn't need the water to circulate.
Right, you see this you see a lot of these in larger buildings.
Yeah, this is going to be in larger homes that usually see recirculating systems, or maybe really large apartments.
Okay. All right, I've got one more question that I see here. And it deals with anode rods, which is something that, I think we're going to do a show in the future on anode rods. So, but it talks about if I run into an anode rod that's really difficult to unscrew, is there any tips or tricks that would help remove it?
Anode rods can be very difficult to remove because, they almost electrically weld itself to the tank.
Over time, yeah.
Over time,
yes.
yeah. As it's breaking down. So if the anode rod, if you find it's difficult to remove, you could put a little bit of penetrating oil on the threads, but the best thing I have found to remove in an anode rod that's kind of seized up in there, especially because it's hard to hold the tank or anything like that, is an electric impact wrench. If you have an electric impact wrench and you have the room to get to the top of it, it'd usually spin it right off. So
yes,
that's what I'd usually recommend. But there may be times where you may have to use a little bit of penetrating oil.
All right, I hope that answers your question. Oh, got one more here. Looks like, is it true that the 80-gallon water heater will be discontinued?
Currently, that is true. The 80-gallon standard residential electric water heater is currently discontinued. It would not meet energy efficiency. So usually an 80-gallon water heater, if you have one to replace it, you'd either have to go down to a smaller size and crank the temperature. But, a lot of people, depending on the installation, they may go to a heat pump design.
Yeah, you go to a different technology, which would be a heat pump in that case.
Yeah, but it all depends on where the water heater's going. So usually in an apartment situation, unless it was an apartment with a garage to where maybe you could use a heat pump water heater, if it's in a small closet, a heat pump might not be the best choice, but if it's in a garage, you could go to a heat pump style water heater. Otherwise, we have some stuff in the works. You could use a smaller water heater and increase the temperature.
Yeah, use a mixing valve. It does work. All right, one more question. It looks like what turns the sink water brown?
Discolored water. Discolored water, and this is a couple different things can cause this, and typically it's caused by iron-reducing bacteria. It's non-harmful iron-reducing bacteria that reacts with hydrogen gas from the anode rod.
Right.
So it gets in the water heater, it gets in the water lines, it starts reacting with the chemical reaction that's going on with the anode rod. It's non-harmful, but it's going to discolor the water. You'll also see this, especially if an apartment or a place stays vacant for a while, the water's not moving, so it's going to get kind of funky. The water's going to get stagnant in a way. And so typically the best way to fix that is to either, in your situation, a lot of times people when they move it, you can flush it all out, but the best way is to increase the water temperature and install a mixing valve. So you'd increase the water temperature up to 140 degrees, install a mixing valve set to 120, and that'll take care of it. If it's a continuous problem, like several people are continually having this problem, it's probably a better bet to install a continuous chlorination system, and that'll take care of it, because you just have to kill the bacteria. It's not actually an issue with the water heater, but it's an issue with bacteria in the water.
All right, well, that about takes care of the questions, and that about covers this topic. But before we go, I really would like for you to put in the chat window what property you're viewing from and the city and state you're in. Just put that in the chat window on the right-hand side of your screen, and you know, we really like to know where you're located. But if you have folks who missed this broadcast, a recorded version will be posted in about 24 hours on our new website, university.hotwater.com. On the website, you can also find other training videos that we have available. You can even register for some of the classes that we have available on that website. But I really enjoyed doing this. And check that website out. There's a lot of stuff on there, good videos that we've done in the past about all different types of water heaters, and we're real excited about it.
We are excited about it. And if you have any questions, just always let us know. I
Yes.
mean, we're always around to answer questions.
Yep.
So.
All right, but for
Kenneth Ezel,
I'm Jerry Winslet. We'll see you next time.